Okay, this is 5.3, Solving Systems with Elimination, Day 2. Sometimes when you solve with elimination, you're going to have to multiply by a constant. These are the steps we're going to follow today. Step 1, we want to ask ourselves, are the coefficients of x or y opposites? If not, how can I make them opposites? Second step, we're going to add the equations to eliminate a variable and then solve for the leftover variable. Once we find one variable, we're going to substitute it in and solve for the other variable. And last step, write the ordered pair. So let's get started. Our first set of equations, our first system is 4x minus 5y equals negative 19. And negative x minus 2y equals 8. So our terms are positive 4x, negative 5y, negative 19, negative x, negative 2y, and 8. Now I don't have any opposite terms, but if I look at my x terms, I do have opposite signs. I've got a positive 4x and a negative x. So the easiest thing to do would be to take this negative x and turn it into a negative 4x. And I can do that using the distributive property here. So I'm going to rewrite that equation. The negative x minus 2y equals 8. And I need to turn it into a negative 4x. So I'm going to take my entire equation here, and I'm going to multiply it times 4. 4 times negative x is negative 4x. 4 times negative 2y is negative 8y. And 4 times 8 is 32. So I've got negative 4x minus 8y equals 32. And I'm going to bring down my first equation, my 4x minus 5y equals negative 19. And let me just cross this one out so we don't get confused. We're not using that one anymore. And I'm going to use elimination to isolate my y variable. So I've got a negative 4x and 4x. This cancels out. Negative 8y minus 5y is negative 13y. And 32 minus 19 is 13. Now I'm going to divide both sides by negative 13. Divide by negative 13. Cancels out. You get y equals negative 1. So now I've got my first variable, y equals negative 1, and I'm going to use substitution to solve for x. Let me just move this over a little bit. I'm going to rewrite one of my equations. I'm going to take negative x minus 2y equals 8. And I'm going to substitute y for negative 1. So negative x minus 2 times negative 1 equals 8. Negative 2 times negative 1 is positive 2. So I have negative, bring down my negative x, bring down my equals 8. I'm going to subtract 2 from the left, subtract 2 from the right. I get negative x is equal to 6. And I want to convert that into a positive. Divide by negative 1, and I get x equals negative 6. So my x term is negative 6, my y term is negative 1, and I can write my ordered pair. Negative 6, negative 1. All right, let's look at another example. In our new system, we're going to have to multiply by a negative constant. So I've got 3x plus y equals 11, and 6x plus 3y equals 24. So my terms are positive 3x, positive y, positive 11, positive 6x, positive 3y, and positive 24. Okay, so I don't have any opposites because all my terms are positive. So I'm going to need to multiply by a negative constant in order to get opposite pairs that I can eliminate. And there's really two different ways I can go. This is the one I'm going to want to multiply, the 3x plus y equals 11. Now I could either multiply by negative 2 to turn this 3x into a negative 6x, which would be opposite, or I can multiply times negative 3, which would turn this y into a negative 3y. So I'm going to go with negative 2, my first option, and I'm going to rewrite that equation. 3x plus y equals 11. And I'm going to multiply the whole thing times negative 2. Negative 2 times 3x is negative 6x. Negative 2 times y is negative 2y. And negative 2 times 11 is negative 22. I bring down my second equation, my 6x. Let me make that an x. There we go. Plus 3y equals 24. Get rid of this one so we're not confused. And now I'm going to eliminate. So negative 6x, positive 6x cancels out. I've got a negative 2y plus 3y, which equals y. And negative 22 plus 24 equals positive 2. So right away, I get to my isolated variable, y equals 2. Then I use substitution, and I'm going to go with my first equation, my 3x plus y equals 11, and I'm going to substitute 2 in for y. So 3x plus 2 equals 11. Subtract 2 from the left, subtract 2 from the right. You get 3x equals 9. Divide both sides by 3, and you get x equals 3, because 9 divided by 3 is 3. So my two terms are x is 3, y is 2. That makes my solution, my ordered pair, 3, 2. And we're done.